Hello, this is Tom with the Tractor Rescue Ranch. This is in progress of the latest build that Scott and I are doing. Scott is wanting to do a soil tester, and there'll be more information a little bit later on it. I'm going to let him explain that because he's the electronics guy. But what we need here is to have a little cart that some coulters can run on and run into the soil. And so we're putting this together. These end pieces with the hubs were just some pieces that come off of an old plow or an old disc that was being scrapped. And so we put them in that pipe. You can see right there to get it tight, nice and tight, we had to get Robbie's help with his machine shop, and we put a sleeves in here and there so that that's good and tight. Hooking onto that bar, we're going to hook that bar to this 3-point hitch piece, and obviously it'll have the wheels on it so that it'll be easier to adjust the depth of it instead of using 3-point hitch. So we're going to go from there with it.
Okay, well, welcome to my very messy shop. Tom wanted me to explain a little bit about how all of this comes together. So what I'm doing is for hay, I should be able to get 4 ton an acre, 2 cuttings, 2 ton per cutting out of my field. And at the moment, my field is producing quite a bit less. And part of that is because we land leveled and we scraped the top soil off and put it into the low spots. And so when we did that, right, the topsoil had better pH, or had a lower pH, and it had more nutrients. And when we expose the lower stuff, right, our nutrients are way out of balance. So I got to plow my field again, but before I plow, I need to add phosphate and potassium and sulfur to balance. But I don't want to spread that throughout the entire field. I only want to put it in the areas where we scraped. Now, you saw that we're using the GPS, the auto steer, which also has section control and rate control. So what it means is we can apply fertilizer at different rates, well, somewhat, at different rates in different parts of the field. So we can apply fertilizer to the entire field and then come back to the spots that need more and put more on in just those spots. But in order to do that, we need some guidance for the software. So we need some additional boundaries, not just the field boundary, so that it knows this area needs more nutrients. So what we're going to do is we've got 6 coulters. 2 of them will be electrified at 12 volts, right? We're building a big ohm meter, and we're going to drag this ohm meter in 20-foot swaths. Now, this is all available commercially, but I'm only going to do it once, so I don't want to spend the $10,000. I'm just going to build it for a lot cheaper. So we're going to electrify, if we count the coulters 1 through 6 coming this direction, we're going to electrify coulter 2, and we're going to electrify coulter 5. And they're going to put a current in. And then we're going to put these 2 coulters 3 and 4, they're spaced 30 centimeters apart. And so what they're going to do is they're going to essentially, because the arc, electricity flows in an arc, that arc will penetrate deeper than the coulters are actually penetrating. What happens is, because they're different arcs happening, the distance of the coulter is which arc it connects to, and then depending on that arc that you connect is the depth that it's measuring. And so these are going to measure about 3 to 4 inches deep, and these ones are going to be spaced at 60 centimeters, and they're going to measure almost a foot deep. I need to go through and review the equation. I'm just basing that on the commercially available one. Well, anyways, what we do then is basically like an ohm meter, but we're going to use Arduino, which is the same stuff that our auto steers running on, and it's easily programmable. They teach kids in high school Arduino, and it will read it'll take readings of the current and compare it against the known or the expected current. And that difference in value tells it if there's different values in the or nutrient profiles in the soil, mostly pH. The salt is conductive. And so if you have higher salt, you'll get a higher conductivity reading. If you have less salt, you'll get a lower conductivity reading. Anyways, once we get those readings, so we're going to run through the field, and each of those readings will get a latitude and longitude position off of our GPS. So then once we put that all into one table, we can put it into software, and we'll have a file with a bunch of points in a mapping software. And then we're going to take a couple steps in the mapping software where we convert those points into pixels. So that way, we pixelize my field, and every pixel gets a value of what the ohm meter is. And then we join the similar type pixels, so those have similar pH values, right? And we can divide the field into different subfields based on the pH. What we do then is we're not set up to really know our mix of potassium, phosphate, and sulfate at that point. But we'll go back in and we'll sample those, and we'll send those off to a soil lab. Utah State University is a soil lab we use. They'll analyze those samples. They'll tell us what the nutrients are for those little subregions in the field, right? And then we can come back and we can calibrate the spreader, and we'll use the PTO driven one, and we'll do different levels, just a few calculations. And then what we can do is we can apply. So this is just the way that we build our map of our field, which tells us, okay, your nutrients in this section are different from this nutrient. So I kind of already know because my windrows, right? Some areas my windrows are really thin. In other areas my windrows are really thick. The teff that we planted, it likes a pH value of 6.4. Most of the field is averaging 7.9. And so I know where that pH is off more because my windrows were off. This just gives me a way to actually put that into my software. So I can, that's why they call it precision agriculture. I can go in with some level of precision and apply the nutrients where they're needed.
Okay.
Hopefully that makes sense.
More videos to come with maybe a better explanation of where we get the information and everything. And so all of the technical stuff is Scott's responsibility. The reason I'm here is to help with the mechanical stuff, these builds. So thanks for watching, and please look forward to some more on this series, and please like and subscribe.